So now we are coming to the chapter 3. Chapter 3 covers analysis. Means if you got bigger circuits, Ohm's law and nodal, node currents and loop equations will not satisfy. So we need some methods. That's called analysis. So we have two basic methods. That's called node analysis and mesh analysis. So we'll study in this node analysis, and we'll study node analysis with voltage sources. So it's also called super node. Why? The node analysis always contains current sources only, generally, node analysis. So if we have a voltage source, then how to analyze the circuit by using node analysis is called super node. So I will delete this topic, which is not useful for your computer engineering in future also. So we will study node analysis. Means item number 3 is deleted. Okay, in notes it is there, but it will not be asked in the future. Now next, another is called second method, mesh analysis. Like a node analysis, we have another method, mesh analysis. Like here also, if we have current source, not like voltage source, then it is called super mesh. Super mesh, that is called when we have current source. Generally, mesh analysis is a voltage source analysis. It has voltage sources, not the current sources. So if we have current sources, then it is called super mesh. If a node analysis have a voltage source, it is called a super node. So generally node analysis, which source current sources we have? Current sources. Mesh analysis, which source voltage, which sources we have? Voltage source we have. Now here also mesh analysis, that is super mesh, I will delete. So only two topics we are studying here now, node analysis and mesh analysis. So today we will finish node analysis, and next class we will finish mesh analysis. Next week we will go for the chapter 4. So that in mid we have chapter 1 to chapter 4. Now coming to, okay, now that we understand the basic circuit theory, including Ohm's law and Kirchhoff's laws like current law and voltage law, we can use them to learn two important circuit analysis method, that is called node analysis, which is systematically applies Kirchhoff's current law, because at a node means current means Kirchhoff's current law. Next, second one, mesh analysis, which systematically applies Kirchhoff's voltage law. Right? This is mesh. Mesh means called loop. What is a mesh? It's a closed circuit mesh. So loop. When loop is there, which law is coming? Kirchhoff's voltage law. So with the two techniques introduced in this chapter, we can analyze any linear circuit by forming a set of simultaneous equations and solving them to find the required current and voltage values. To find the required current and voltage values, we can find. How to analyze? We have 2 or 3 methods. In that, only 2 I will discuss. That is called elimination technique method and Kramer's determinant method, matrix method. So we will study that one. So total 4 topics we can say. 2 means one is node analysis, one is mesh analysis. In node analysis, 2 techniques, that is elimination technique and matrix method technique, Kramer's method. And same thing, mesh analysis also 2 techniques. So total 4 items we are studying in the chapter 3. So what is node analysis? Node analysis provides a general procedure. For analyzing circuits using node voltages. Generally at node, what will be there? Current entering, sum of current entering equal to sum of current leaving. So this is one equation. In this equation, remove the current and put voltage equation. I equal to, what is the equation? Ohm's law, V by R. So first node currents at particular node, one equation will come. Rearrange that equation with Ohm's law with the voltage. So it's called voltage, node voltages. That's why we call it node voltages. Now, if you find that node voltages as a variables, once you know the node voltages as a variables and you will solve the equations and you get the voltages, then resubstitute into the current equation. Then you will get the currents also. To simplify matters, we shall assume in this section that currents do not contain voltage sources. Means current sources is there only there in the node analysis, no voltage sources. In the later section, that is in super node, we will substitute the voltage also. Okay, in node analysis, we are interested in finding the node voltages only. Given a circuit with n nodes, generally any circuit, how many nodes will be there? N nodes. Okay, in that one node will act as a reference node or zero node, or zero voltage node will act as. By default, in the question itself, we will give which is the reference node or which is the ground node. That zero node also called as ground node, reference node or zero voltage node, where there is nothing will be there. The voltage value is zero. So no need to write any equation, Kirchhoff's current law equation for that node. So how many nodes remaining now? Maybe n nodes are there. One node will always reference node or zero node or ground node. So one node will be there. So remaining nodes will be n minus 1. So that n minus 1 nodes, we need nodal voltages or Kirchhoff's current law equations for those n minus 1 nodes. So we are solving only n minus 1, not n nodes. What are the we follow 3 steps. First one, select the node as a reference node. You can select, or in the question it can be given. In the question, the ground node will be given, or you can select any node as a reference node, up to you. Later, if it is not a reference node, it will give us some value. So generally, in the question itself, we will assign this is a reference node, we will tell. This is a ground, we will tell. So now assign voltages V1 to Vn minus 1, because one node is already reference node. So how many nodes remain? N minus 1. So each node will be voltage V1, V2, V3 up to Vn minus 1. For n minus 1 nodes, we will assign it. First node, second node, like that up to n minus 1. Now so apply second one. Apply KCL, Kirchhoff's current law, at each node. That is up to n minus 1 node, that is called non-reference node. If the one is reference node, remaining all nodes are also named as non-reference node. Okay, so that n minus 1 non-reference nodes, we have to write Kirchhoff's current law equation, I plus I1 plus I2 plus I3 equal to I4 plus I5 plus, like this, one equation. Now arrange that equation with Ohm's law, which is I equal to voltage divided by resistance for that particular branch, to simplify. Okay, now last one, solve the resulting simultaneous equations to obtain the unknown node voltages. Only 3 steps. 4 steps generally, because here we are rearranging Kirchhoff's current law with Ohm's law. So another step we can say. So in 4 steps we will complete it. Now come, the reference node is commonly called as a ground, since it is assumed to have a zero potential. Voltage value is 0 at that reference node. Let's have one circuit here. What you are observing in this circuit? How many branches? Anyone? Come branches. Branch, elements, branch elements. How many? Okay, branches equation you can apply. What is branches? B equal to number of nodes plus number of loops minus 1. So nodes how many? 1, 2, this is 3 nodes. Plus how many loops? This is 1 loop. This is the second loop. This is the third loop. So 3 plus 3, how much? 6. Minus 1, how much? 5. How many branches? 5. How is selling 6? 1 current source is 1 branch. This current source, another branch. R1, R2, R3. 3 branches. I am telling branch. Ground is a node. Ground is a zero potential node. There is no, see, ground is zero potential node. It's not an element. Elements are resistance, capacitance, inductance, voltage source, current source. These are the elements, right? Or branches, we can say. Elements, branches are same. Okay. Ground is just like a zero. One node. Ground is one node, which is a zero connected to the earth. Nothing is there. Okay, good point you asked. Okay, so ground is now, it is already given, which is the reference node. This is a reference node, it's named as 0. Now, node 1, node 2, already we marked. Okay, now what is the next step? We have to find the Kirchhoff's current law. For that, what we note, we need a current numbers, I1, I2, I3, right? So first, I1, this is the current already there. This is I2, already there. So no need of any current numbers. Later, we will put some numbers for the problems. Now here only for explanation. So for this R1, what will be the current? It will be from this node 1 to ground. That means current is going down, we can say. Means higher potential to lower potential current will flow. Will you agree or not? What is the current? Always flow from higher potential to lower potential. Where is the lower potential here? 0. So it will flow from 1 to 0. Node 1 to 0. So current direction is downwards. Same R3. From node 2, the current direction is downwards, means leaving the node. Now the problem here, node 1 and node 2, for the R2, what is the current I2? Current I2 will be from this node. You can assume current direction from 1 to 2 is from left to right. Or you can assume current direction from right to left also. Up to you. When the natija will come, when the result is coming, minus sign will come. That is saying that what you assumed is wrong. But no problem. The steps are correct. What you followed, steps are correct. If minus coming in the result I2, then you have to change the direction. What you assume direction is wrong. Okay. So you can assume anything here. I will assume generally left to right. So what is the current direction? 1 to 2. Means current is from SR to ME. Check here. Okay. See, I assume SR to MN I2. Remaining okay as it is. That is V2 to 0. That is top to down. Here also up to down. V1 to 0. Now, step 2, what we are telling? Kirchhoff's current law. We have to apply at each node. So, what is the first node? This one. First node. What is the current centering in the first node? How many branches first? 1, 2, 3, 4 branches are there. So, how many currents? 4 currents. So, how many currents entering? Summation equal to how many currents? Leaving summation means sum jama. So, what are the jama for entering? Means jua. This node, how many currents entering? V1. This node. This I1 is entering, jua, right. And I2, no, leaving. I1 is leaving. I2 also leaving, right? Only one current is entering. So, I put I1 here. Capital I1. Now, what are the leaving? Capital I2, small I2 and small I1. So, I2 plus I1 plus I2. These are the leaving. First. Next, second node. What are the currents coming? Entering, small I2. Capital I2 is also entering. Only leaving is I3. Right? Correct or wrong? Check here. How many currents are entering? Jua, I2 and small I2. And leaving I3. So I will write small I2 plus I2 equal to V3. Now, what is our step 2 in part 2? Part 1 is finished. That is Kirchhoff's current law. In step 2, part 2 is apply Ohm's law for each current. So, each current. This current already known. There is no Ohm's law here. Direct current is there. Because only current is there. We can't write Ohm's law there. So, for resistance, we can use Ohm's law. V is equal to IR. Right? So, for small I1, I2 and I3, we apply Ohm's law. Now, there is a term. Current flows from a higher potential to a lower potential always. Like V1 to 0, higher potential to lower potential. V2 to 0, ground, lower potential. So, we use equation I equal to V higher potential minus V lower potential divided by R, Ohm's law. V higher minus V lower potential divided by R. Lower potential for this V1 to this ground. What is lower potential? 0. So, V1 minus 0 it is. For this R3, what is the higher potential? V2. What is the lower potential? 0. V2 minus 0. So, V2 only it is. No problem. So, like this we have to arrange. Now, for this R2, what is the higher potential? Because current is from left to right. We assume left to right. So, when current is moving from the resistor left to right, which is the higher potential? V1 will be higher potential and V2 will be lower potential. So, V1 minus V2 will come. If the current direction is in the opposite direction, reverse I assume, let us take, then V2 minus V1 we have to write. Work done. How the work done of the current? Work done will be from starting point to the ending point. Current is starting point is V1, ending point is V2. So, starting point more work done. At the end, it becomes 0. There is a work done. So, V1 minus V2 here because of this current direction. If the current direction is reverse, it is V2 minus V1. Okay, now come to first one. What is I1? V1 minus 0 divided by R1. And we can write in terms of conductance 1 by R1 G. So, G1 V1. So, what is I1? V1 minus 0 divided by R1. Next, I2. This is the I2. So, this is I2. V1 minus V2 divided by R2. V1 minus V2, Taksim R2 divided by R. We can write 1 by R2 is G2, V1 minus V2. In conductance also we can use, no problem. I3. Where is I3? This one. V2 minus 0 divided by R3. V2 minus 0 divided by R3 or V2 by R3. And 1 by R3 is nothing but G3. So G3 conductance. You can use like this also. Same thing. Now substitute these equations, Ohm's law values in the two Hubble equations. First node Kirchhoff's current equation, second node Kirchhoff's current equation. So first node Kirchhoff's current equation, what we wrote in the previous slide, I1 is equal to I1 plus I2 plus capital I2, right? So right, I1 is equal to capital I2, I1 plus I2. What is I1? We have here V1 by R1, V1 by R1. What is I2? V1 minus V2 by R2. So we have to rearrange this equation and write in terms of V1 minus V1 and V2, which is equal to a constant. Now next, for second node, what is the second node? Second node, currents entering are I2 and small I2. Currents leaving is I3. So I2 plus small I2. What is small I2 here? V1 minus V2 by R2, small I2, which is equal to I3. What is I3? V2 by R3, V2 by R3. Now rearrange this equation in terms of V1, V2 or V3. V3 not there, V1, V2 only. Then you can solve in two methods. That's called elimination techniques and Cramer's. Or you can use in terms of conductance also. These R1, R2 you can use in terms of conductance. So same equations in terms of conductance. Now how to solve? How to solve this equation? Okay. Yeah. Node voltage using the standard method such as substitution method, elimination method, that is called, or Cramer's rule method or matrix inversion method. We have two methods here: elimination method or standard method, or Cramer's rule or matrix method, matrix inversion method. We will study both. Okay, this is called matrix method. How we are arranging? We are arranging. See, we just rearrange this in terms of V1 and V2 for this equation. V1 and V2, if we rearrange in terms of conductance, then it will become G1 plus G2 times V1 minus G2 times V2, which is equal to I1 minus I2. Next, another equation is minus G2 times V1 plus G2 plus G3 times V2 is equal to I2. Like this, we have to arrange. We'll see in the example, we will understand easily. So, any doubts in this? We are going for the problem now. This is only for the steps what we are involving. Okay, one example is here. Calculate the node voltages and node each branch current. Node voltages you can stop, or currents also you can find. So here, just wait. Okay, this is a circuit. How many branches? Anyone? 5. As same like previous, like 5 branches. Then where is the reference node? This is the reference node. This is the reference node, or this? Which is the reference node? Zero voltage node. Which one? Ground. This one is a reference node. I will name it as 0 there. Okay, 0 node. Now remaining two nodes are 1 and 2. Okay. Now currents. Currents, I will put currents, all branches I will put some current number, current names. Okay. I will put 5 amperes as a 1, let's say. So I1 will be 5 amperes in this direction, entering the node. Okay. Then check here. I1 I will enter in the node. Then I2 will be in 4 amperes from V1 to V2. Now I3 will be from V1 to 0, I3 down, because higher potential to lower potential. Then I4 is from ground to V2. Okay, I4 is this one entering the node. Then I5 from V2 to ground. Understand how to? Just you can put your own direction of the currents. Only you have to check what is this direction. Remaining in resistance, you put your own directions, no problem. Okay. Now, Ohm's law, first step, Kirchhoff's current law at node 1 and node 2. Node 1, what are the currents entering? Anyone? Come, branches, 1, 2, 3 branches. What are the currents? I1, I2 and I3. How many entering? Juba? 1, that is I1, right? How many leaving? I2 and I3. So, I1 is equal to I2 plus I3 I can write. Now, what is I1? Rakam Mojud, Khamsa. 5 is equal to I2 plus I3, right? See here. I1 is equal to I2 plus I3. So what is I1? Already we know. I2 is already given, 5 amperes. So 5 amperes, which is equal to I2 plus I3. Now what is I2? This is I2. Nothing but V1 minus V2. Taksim R. V by R. Okay. So V1 minus V2 by R. Plus what is I3? When are the I3? This is I3. What is the voltage? V1 minus 0. So V1 minus 0 by 2. So one equation. Now rearrange. Always tell rearrange in terms of V1 and V2 on one side, remaining constant value, any value on the right side. See, we can rearrange this by solving. Take the LCM 4, then it will go here 20, and you rearrange this one. It will become V1 minus V2 plus 2V1. Now you can write the equation in terms of 2V1 plus V1, 3V1 minus V2 equal to 20. In this format only you have to write, which is useful for two method of analysis. One is elimination technique also you can do if you write in this format, V1 on variables on the left side and non-variables on the right side. And in the matrix method also it is easy for you because we have to form matrix. Now first node finished. Now second node, what are the currents? How many branches connected to the second node? 1, 2, 3 and 4 branches are connected. So 4 currents will be there. How many currents are entering the node? I4, I2. Good. I4, I2 are entering. Next, I1 and I5 are leaving. So write the equation. I4 plus I2 is equal to I1 plus I5. I2 plus I4 is equal to I1 plus I5. But what is I1? Khamsa. What is I4? Ashra. So I can write I4 as a Ashra, then I5 as a Khamsa, I1 as a Khamsa. Now what is I2? Where is I2? Yeah, I2 is nothing but V1 minus V2 divided by 4. V1 minus V2 divided by 4. This I2. I4 is Ashra. Now I1 is Khamsa. What is I5? This one. V2 minus 0 divided by Sitta. V2 minus 0 divided by 6. So now rearrange this one. You will get some equation. Then you will rearrange that one. You will get in terms of V1 and V2 as a minus 3V1 plus 5V2 equal to 60. So how many equation we got? Here one's equation, another equation. Now by elimination technique. What is elimination technique? Just put V1, 3V1 is equal to 20 plus V2. Now V1 is equal to 20 plus V2 Taqsim Talata. Substitute this in here in the 3V1. Then you will get the V2 value. Once you get V2 value, again substitute back in this equation. You get V1 value. That's called elimination technique. See here. Elimination technique. Then we will get the V2 is 20. Then V1 is we will get 13.33 volts by using elimination technique. But I prefer good methodology. You are engineers, use matrix, because all tools in your future, MATLAB, bigger tools, always follow matrix methods, right? So understand matrix, it will be easy for your what we call another calculus or engineering mathematics. 2 courses are there for you. There also we use this technique, matrix method. It will be easy for you, calculus and everywhere. Matrix method, eigenvectors, vectors also matrix needed, that also there. So practice matrix method, not the elimination technique. Elimination technique everyone knows. Any other students, non-engineering student also can solve, right? So better go for the matrix method. I prefer that one. I will explain how to do that one. Easy method that is. Now in the previous, the equation, what are the items? V1 and V2. Just check here. Sorry, I have to write here. I forgot. Okay, what is the first equation? 3V1 minus V2 equal to 20. Remember this one. What are the items? 3 minus 1 and 20 horizontally. Okay. Second equation. Minus 3 V1 plus 5 V2 equal to 60. What are the items? Minus 3, 5 and 60. Now check here. You have to arrange the matrix, these two equations in this format. 3 minus 1, 20. Minus 3, 5, 60. Now multiply this, you will get same equation. 3 V1 minus V2 equal to 20. Same. Minus 3 V1 plus 5 V2 equal to 60. Same equation. Okay. So in matrix format, we have to put like this. All the coefficient we have to write. Then put V1, V2 in the column vector. Then on the right side column vector, the other side of the non-variable term. Okay. Now once you get this one, we have just 3 steps. What are this? First take the determinant of this. Then V1 is nothing but remove the first column to keep 20 and 60 here. Find the determinant divided by the actual determinant. Same. Remove the minus 1 and 5. Keep the 20 and 60 here. Take the determinant divided by actual determinant. It will be V1 and V2. No need of any elimination here. Check here. First find the determinant. What is the determinant equation? Diagonally multiply minus. Diagonal. What is diagonal? 3 and 5 is one diagonal. Other diagonal, minus 1, minus 3. Diagonal, cross. Okay. So, 3 multiplied by 5. How much? 15. Minus. Minus 1 multiplied by minus 3. Plus 3. That is here. You will get 12. Here, everyone understand or not? Please tell me. What are you going to do? Determinant. What is it? How do you find the determinant? Diagonally, you have to multiply. Put minus in between. First diagonal, 3 into 5, 15, minus Lazim. Then this diagonal, 3 into 1, 3. Minus, minus, it will plus. Minus is main important. Okay? Diagonal. It will continue. You have to, first step itself, we don't know, then complete problem is gone. So, determinant 1. Now, next step is for V1, finding the V1, we need to eliminate this first column, keep this column here and find the determinant. So, V1 is nothing but determinant 1 divided by actual determinant, main determinant, total determinant you can say. So, determinant 1 is nothing but remove the 3 and minus 3 with 20 and 60. 20 and 60. Keep as it is this column, minus 1, 5. Now, find determinant for this. What is determinant? Diagonal. 20 into 5, how much? 100. Minus 60 into 1, minus 60. So, minus of minus, plus. So, 100 plus 60 divided by, what is actual determinant we found here? 12. So, 160 divided by 12, 13.33 volts. See here, how much we got V1 in elimination technique. Same? Okay. Now, V2. V2, we have to remove the second column, minus 1, 5. Then, we have to put 20 and 60 here. So, 20 and 60 here, keep it here. So, 3 minus 3, 20 and 60 your matrix. Now, find the determinant of this. Diagonal, 3 into 60, 180. Minus 20 into 30, 20 into 3, it is 60. Minus of minus, plus. So, it is 180 plus 60, that is 240 divided by 12, 20 volts. Right? Okay. So, here, what is V1? Where is V2? V2 is 20 volts here. Here also V2 we are getting. So, like this, we have to find the node voltages. Next, currents automatic. Substitute in the Ohm's law, we will get the currents. Like I equal to 5 amperes. I2 is nothing but V1 minus V2 by 4. So, substitute what is V1, what is V2, we will get minus 1.6. I3, V1 by V2. V1 by 2, that's 6.66. Now, observe here. I2, what is the current? What is I1? Plus 5. What is I3? Plus 6.66. Find I2. Why it is minus? Anyone?
Because it's wrong direction.
Yes. What we assume is wrong direction. No, it's not a fault. It's not a fault. Perfectly you went the steps. No problem. The result tells that the direction what you assume was minus. Means reverse. No need to do anything here. You can understand that's it. Okay. If it minus is coming, you can understand that, oh, I put wrong direction. It's okay. Okay. It should be in the reverse one. If you, in official itself, you put the reverse direction, it come here positive. Value will same. Value 1.66 only. It will not change. But direction will tell the sign. Plus or minus. So, this is the one we have. See. The fact that I2 is negative shows that the current flows in the direction opposite to one what we assumed. Okay, another example, then we'll finish. Yeah, very soon. Okay, this is the circuit. We want Ix, this is a dependent current source is here. This is a different circuit. Ix is depending on this current source to Ix here. So now put the reference node, this is one. And this is first node, second node and third node. Okay, 3 nodes now. Previously it was only 2. Now it is 3 nodes here. So currents, put the currents. This current is there. This current is there. Here current, here current, here total currents we can put. So this current 3 amps. And I put I1 in the 4 ohms. I put I1 in the direction I assumed like this. Leaving from node 1, entering in the node 3. Now I2, in the 8 ohms. Because I cannot take some number here because already Ix is given. So I can take Ix as it is, no problem. Now what is I2? From V2, leaving from V2 and entering in the V3, node 3. Now I3, leaving from node 2 and to the ground. Okay, these are the 4 currents. Now, what we have to do now? We have to apply nodal equation for this node V1, V2, V3. First node equation, current's law, Kirchhoff's current law, number of currents leaving summation equal to number of current entering summation. So what is the currents entering in the node? What are the currents entering? 3 amperes equal to, because only one is entering, remaining is leaving. So 3 amperes equal to I1 plus Ix. Okay, this is the first equation. Now what is I1? What is I1 in Ohm's law? V1 minus V3 divided by 4. What is Ix as per Ohm's law? V1 minus V2 divided by 2. Just rearrange in terms of V1, V2, you will get first equation. Second one, at node 2, what are the equation? Currents entering, Ix is entering, leaving I2 and I3. So Ix is equal to I2 plus I3. So what is Ix? V1 minus V2 divided by 2, Taksim 2. And what is I2? V2 minus V3 divided by 8 plus. And I3, V2 divided by V2 minus 0 divided by 4. Same, coming to the, rearrange it, you will get in terms of V2, V1, V2, V3 here. No problem. Now, third node, what are the currents entering? I2 and I1. What are the currents leaving? 2Ix. So, I2 plus I1 equal to 2Ix. Now, what is I2? V2 minus V3 divided by 8. Next, what is I1? V1 minus V3 divided by 4. Now, what is 2Ix? Ix we know. What is Ix? Here. Ix is here. So, V1 minus V2 divided by 2. Okay. Ix is nothing but is here. Ix is here. What is given in the question. So, V1 minus V2 divided by 2. Now, rearrange this. It will come in terms of V1, V2, V3. Now, we'll write here. See. Same thing. It is coming in this equation. 3V1 minus 2V2 minus V3 equal to 12. One equation. Then, at node 2, Ix equal to I2 plus I3. Now rearrange everything. Minus 4V1 plus 7V2 minus V3 equal to 0. At node 3, I1 plus I2 is equal to 2Ix. Now substitute what is 2Ix? 2V1 minus V2 divided by 2 will cancel. And we substitute, rearrange this. 2V1 minus 3V2 plus V3 is equal to 0. So this is one equation. This is another equation. This is third equation. All are containing V1, V2, V3. Variables on the left side, non-variables on the right side. So, by elimination technique, you will get V1 and V2, V3, 4.8, 2.4 and minus 2.4. Elimination technique, you can get it. But I prefer matrix method. Okay.